Can you hear me? Hello?
Hi.
Hey.
So I don't know exactly what's going to happen here. Normally I try to have a guest, but it's been hard to get guests to be willing to come. So we'll see. Worst case, we'll just speak about APL's history.
Okay, sounds fun. By the way, is my audio okay?
What? Sorry?
Is my audio okay?
Yeah, it's okay. It's a little bit like a tin can, but it's okay.
Okay. Yeah. Can you join in Zoom with phone? Because my phone has a better mic.
Yeah, yes, you can. It should be fine.
Yeah, give me a minute.
Good morning.
Hello.
You asked me last time, what did I use APL for?
Yeah.
And I I was taken off guard by the question, but I started listing things that I did with APL, and it's a long list.
So, okay.
Now who's Brian?
I don't know.
I'm
We'll find out when he gets his phone connected.
well, I hope my voice is too bad, but I'm from Faroe Islands. I got recently introduced to APL like 3-4 weeks ago. And I've been loving the language, absolutely loving it. It's amazing.
Cool.
I loved Python and JavaScript, and I was looking for like a beautiful language because like I saw this huge difference between Python and JavaScript, and I wanted like, and then I programmed a bit in Python, and I realized it's very annoying with the if statements and loops and stuff. I got really annoyed. So when I saw APL, I was just blown away. Like, absolutely amazing. It's so beautiful. Yeah.
Yeah, well, you're not alone, I guess. People have been.
I heard of APL as being a powerful language. It sounded kind of intimidating. But when I arrived at IBM as a summer student in 1974, one of the people handed me a copy of Paul Berry's APL primer. And I took it home and wrote some APL to produce address labels, which was really Fortran with funny symbols. But I found APL very, very useful and have been loving it myself over the years.
Yeah.
Me, like myself, I've been making this game in APL, right? And it's like with array maps, right? And it's like using a game engine, but I have everything to myself. There's no background program, and I thought it would be really hard to program something like this because I thought a game engine was too huge to program again, right? Like myself. But if I focused on just one type of game and one genre, and then like, and everything just follows. It's like I've only written like 10 lines now, or 20 lines, and it's already like running really well. Like array of like I have a map, I have random generation, I have set pieces now that I'm programming in, and like it's great. I can't believe I've made so much progress in such a short time.
Are you aware of the Stormwind Simulator? Have you heard about it?
Wait, is it the thing that like a Norway rescue kind of thing, a simulation or what?
Yeah, well, it's Finnish actually, but yeah, it's a boat simulator, but a professional one used by coast guards and militaries and police forces and so on to train people before they let them loose on the real waves. And obviously there are plenty of simulators out there. This one, and there are plenty of commercial, like not for fun simulators out there. But this one is remarkable in being written in APL, almost the full stack. There's a 3D engine that's not APL, that APL then instructs what to do when there's translation layer written in C for them to communicate, if I remember right. But all the logic, all the formulas, everything is in APL. And what's further remarkable about it is that it's a single person that has written the whole thing from scratch. So yeah, it's definitely possible to write that kind of thing.
Yeah, it's incredible how much like how much you can program in such a short time, and like how fast you can write APL compared to other programs.
Yep.
The Stormwind Simulator, was it at APL Seeds that we had a really nice talk on the use of that for tracking down the location of a ship?
Yes. No, hold on. The simulator was not used for tracking down location of a ship. There was a APL user meeting where Thomas Gustafsson, who is the one who has created it, maintains it, spoke about tracking down the location of a ship. And I suppose the formulas that he has developed in developing Stormwind is what he kind of applied in reverse, not trying to simulate directly where is what happens to the boat right now, but more backtracking and seeing where would things end up under these circumstances, kind of thing. So he's applying his knowledge using APL as his simulation tool, but not Stormwind directly. However, that said, APL Seeds, he did give a talk about not the Stormwind simulator directly, but about using APL for 3D manipulation of objects, kind of thing. That was quite popular.
Yeah, I'm trying to think of what would be the most interesting talk for Brian to look at.
Yeah, I can have a look at the APL Seeds. You heard about APL Seeds before?
I have not.
I'll put a link to you in the chat here. So hopefully there will be another APL Seeds in a few months or so. People need to arrange it.
I'm going to join with my phone. Hopefully it's going to be better. 1 second.
Oh, now we can see you as well.
Oh yeah. Wait. Wait. So it asks me, like, can you guys still hear me?
Yeah, but I'm not
It
sure.
asks
But we're
Wi-Fi
hearing
or
you from your
cellular data. Sorry,
oh,
what?
we're hearing you through your computer.
Okay, yeah. Wi-Fi or cellular data, it's asking, or it's asking dial-in or no audio.
Well, you probably
Dial-in?
want to, if you have Wi-Fi, you probably want to use your Wi-Fi. Otherwise, you'll be spending money on your. Okay, I've muted you on your computer. Okay, you dropped out anyway.
Yeah. Okay, so you can see me.
Yep, we can.
Great.
Hello.
Hello. The reason I didn't join with my camera on my computer was the camera is not working on my computer.
It's a good reason. But are you actually Faroese? You don't?
Yeah.
Okay.
Actually, the Faroese.
With the name Brian.
Yeah.
It seems unusual for the Faroe Islands, but okay.
I mean, my parents liked giving universal names. My sister's called Maria, which is pretty popular.
Yeah.
Yeah.
Cool. I was just wondering, the name was kind of not what I would classically connect with the Faroese. So
how do you spell fairies?
Yeah.
How do you spell that name?
Faroese. Oh, well, in
it's spelled
English,
funny in English. It doesn't make any sense. That's not how it.
Okay, wait, I hope I can still send in chat. Well, no, I can't send in chat on my computer. Ugh.
I'll find it for you.
Yeah, so like you spell Feroe, like Pharaoh, and then
I think it's FA, by the way.
Faroese, Faroese. But in Faroe Islands, you spell it like F-R-O-I-R.
These names of the letters are very different from what Curtis is used to. It begins with an F and then it goes to an AE ligature, right?
AE literature. I don't know what that means.
The letter A in whatever.
Oh yeah. No.
No, actually no. In fairies, it's with an no.
Yeah.
I
Oh,
keep mixing
or-
up. So it's an O with a slash, like computer programmers type a 0 is the
Yeah.
second letter, and then ROYSK.
OY is like theoretically one letter in Faroese. I don't know why, but it theoretically is. It's like an alphabetical character because like
Yeah,
it's weird. It's because
it's like
like
English has plenty of those TH and GH and the OU and the
yeah, but it has to be added in Faroese because Faroese doesn't allow two what are they called?
two vowels after each other.
Two vowels. Yeah, two vowels next to each other. Yeah,
Ah, interesting.
it's
So,
weird.
so where is it?
It's in the. It's like above England.
It's a
or like
midpoint between United Kingdom, Norway, and Iceland.
Ah,
And it's part of the Kingdom of Denmark. So
Yeah.
Brian and I have the same citizenship,
Yeah.
but our mother tongues are different.
Mm.
So then most people are not aware that Denmark is a union of 3 countries.
Although I do speak Danish, so
yes, very well.
yeah.
So yeah,
So let's see, Adam, you want me to kind of go through some of the things I've used APL for?
yeah, sure.
Yeah.
Brian, this may just bore you to tears.
No, dude, I've watched about 7 hours of just Campfire. I've been loving it. Go for it.
Yeah, I mean, the last Campfire, Adam asked me what have I used APL for, and I was caught really flat-footed on that one. And so, I mean, the story is that my major professor ran out of money. I was at Purdue University. Well, you know, I've finished my PhD at Purdue, but it took some doing. But so when my major professor ran out of money, he got one of his former students who worked for IBM here in San Jose, California, to hire me as a summer student working on magnetic bubbles. And so
Do you say magnetic bubbles?
magnetic bubbles. It was a scheme to store data. The normal bubble memory consisted of, is there a bubble present at this point or no bubble present at this point? And Otto Fergeli, who was the manager who hired me as a summer student, realized that the state of the bubble could store the information. So you could have an array of bubbles, some bubbles with twists in the wall of the bubble, and some bubbles without twists in the wall of the bubble. You know, and so the state of the bubble determined whether it was a 1 or a 0. And you could determine the state of the bubble by seeing which direction the bubble moved when you put it in a magnetic gradient. And the thing that Otto was interested in for my summer was, you know, how stable is that state of the bubble? And so the job that the summer job I had was basically putting a bubble over a fairly large conductor and running it back and forth and see how many times it could go back and forth and retain its state. I mean, this is not terribly interesting, but you know, the APO was not terribly interesting, but you know, that was my first the magnetic fields of the current through finite length rectangular conductors and put together an APL workspace for calculating the field of an array of conductors. I should say that one of the things that really attracted me about APL was the find plot function. You know, I could produce plots really easily with APL, and I used that a lot throughout my career at IBM and beyond.
So this was a workspace or that was supplied
was the workspace I wrote.
The fine plot one?
What?
You said you used fine plot, no?
Yeah. Oh, FinePlot. No. FinePlot was one of the workspaces that was around.
Let's see if I remember this right, because this was all
FinePlot, I think,
theoretical to me. FinePlot was a workspace that allowed you to replace the type head in the printer with the character set consisting of dots, right? And so that it was
Right.
able to pretend that it was using characters, but it would actually print little dots, and it was able to have a high resolution graphing ability on a text printer. Fancy
Yes,
stuff.
indeed. Yeah, and the original FinePlot ball actually had characters for drawing blocks, and so there were corner characters and side characters and top characters, and so there actually was a workspace that was put together to produce very large print that I used occasionally. And then there was a later FinePlot ball that was produced that had the array of dots in the different positions in the character position, and array of circles in the character position, and an array of little squares in the character positions. So that means you could produce curves with dots, and curves with circles, and curves with little squares. And that was extremely helpful in my work. And indeed, the substance of the thesis that eventually got me a doctorate was that you could determine the mass of a magnetic bubble by putting it in a rotating gradient that drove the bubble into a circle. And you could observe the bubble with a microscope with proper polarization, and the diameter of the circle as a function of the drive gave you the mass of the bubble. And anyway, so the really core of my thesis was a simple plot. Good morning, Ron. You remember the FinePlot ball, don't you?
Remember plot and FinePlot, both of
Yes.
them. Yeah.
So plot didn't use a special type head, right? It would just
No, plot uses special. There was a couple of different type bulbs that were developed. I mean, one was sort of a more general purpose type bulb before in fact, that type bulb was probably developed before APL even.
No,
the first
no,
plot.
because there's no, that one was marked APL plot on the top.
Oh, was it? And then there was a later plot ball that had the circle, square, and the quad plot characters, which I used for most of my work. And indeed, I kept there's an IBM 1651 terminal, which was a repurposed magnetic tape selectric typewriter. I kept that around until the APL for the PC had a GraphPack workspace, and I could produce decent plots.
it's very different. On the PC, you're drawing it on a cathode ray screen. And
no, actually, it was on a graphics printer. The plots that I used.
yeah, originally I'm saying, but that's the amazing thing in the original plots you were making. They required dedicated hardware to produce.
Oh, the finest plots came out of the Tektronix terminals attached to a 3277 tubes. I think those were probably the way you could get the fastest, highest quality plots, but I never had one of those.
Wait, hold on. The Tektronix ones, which kind of printer was that?
It was a thermal printer.
Ah,
I mean, horrible paper.
yeah. So it's a fax machine, or what people connect with an old-fashioned fax machine.
Like Fax Pro.
Let's see. Don, do you know John McGrew?
Yeah, of course. Well, I mean, only from online, but and by name, obviously.
Yeah. Well, that's right. Yeah, you had lots of discussions about the logo.
Yeah, and other things as well. But Curtis, by all means, go on. So
Okay.
so you're drawing graphs of magnetic bubble memory.
Yeah, but one of the things where APL was really helpful, and this is where it kind of shines as a tool of thought. When I was working on designing coils to produce fields for the magnetic bubble memories, I realized from work I had done with least squares, partly because work I had done with APL using least squares, I mean, going beyond the simple quad divide, I realized that you could trade off the power dissipation in a coil for field uniformity. And that was very easy to do in APL. I was very proud of the TR that I produced, technical report for designing coils for things like bubble memories. Although I don't think anybody ever actually read the thing. But I thought it was really neat. And then a few years later, I think one of the reasons Silicon Valley is successful is because there's so many technical people around. And there are some people who lived in the neighborhood, a guy who lived in the neighborhood who had a bookstore, so to speak, outside his house on the street in San Jose. And, you buy a book and put 50 cents in the box. And there was a book by Francis Bitter, who was an eminent magnetician, which is a biography. I got the book, read it with great interest, and realized that Bitter had done the same sort of thing, generations before I did. But so my original idea wasn't so original, but it was a really great idea. And APL made that possible. Okay, so now I'm coming to an area where I didn't do anything, but there's a story. It connects with the calendar workspace that is in Tri-APL2. The calendar workspace, arrived before Tri-APL2, and it goes back to Howard J. Smith Jr. John, of course, knows Howard, or knew Howard. I mean, fortunately, he's gone. But Howard was, one of the important mentors for me. Gene McDonald did describe Howard as he says without going what goes without saying. But Howard had lots that was helpful for me. And Howard also, recognized that the current calendar system with the 400-year cycles and the 1,000-year cycles would still be inaccurate after a long time, and gave a talk to the APL Bay Area users group about the problems with the calendar system as it is now, and proposed a function for doing calendar work that was a fairly long function. Dick Connor, also the late Dick Connor, looked at that and submitted a one-line APL function to generate the Julian day number. It's just kind of a joke as a response to Howard's fairly long function that had added some extra cycles. Now, Dick Connor had developed that function in Fortran using the Flinders and Van Flandern algorithm. So it could be done in one line of APL. And that line of APL has made it into the idioms workspace that comes with IBM's APL2. But Dick Connor said that he wrote the Fortran routine to impress a female programmer at the time. But he had to put it in one line of APL to respond to Howard J. Smith's fairly long function. So that's how that got into the calendar function. I'll have a little more to say about Tri-APL2 later. Gene McDonald's response to the whole thing was, I agree with the Pope. Now, John recognizes how funny that is. The calendar comes out of.
Oh, now I see. Yeah, okay, I get it. I just found it, by the way. The APL2 comes with the idiom library, and it has two formulas there: conversion to and from Julian day number. Yeah, they are one-liners. Although they have been updated to use modern day APL, they use nested arrays. Surely that wasn't the case at the time.
At the time, I mean, it was flat APL, but I did most of my playing around with Dick's calendar workspace in APL2 PC, I think.
Oh, so then, but then you could use nested arrays. Yeah, okay.
Yeah. But okay, so on to, the idioms workspace, which you have just seen. There's a bit of a story about how that got into the system. Paul Berry phoned me, and I forget what year it was, but he asked if I could ask Jim Brown to release IBM's list of APL idioms for the SIG APL. And I'm not sure if I may have communicated that request to Jim Brown, but Jim wouldn't be the guy who'd be able to get the stuff out of IBM. But the list of idioms was being maintained by a guy named Stan Kaysen in East Fishkill. You see John's nodding. In fact, I don't know that I've ever actually met Stan or not. I mean, this is all communications, email in the day,
Right.
And on the conference discs. And so what I did was I suggested to Stan Kaysen that he put the idiom list into a technical report that then people outside IBM could request if it was not if the TR was not internal use only. Well, I was a little devious there. No, I mean, I told Stan why I wanted him to put it into a TR so it could get beyond IBM. And Stan sort of took the idea and he went way beyond that to produce the idioms workspace.
Oh, instead of just, yeah, okay.
Yeah.
And those workspaces were open for anybody to use then?
Yeah, well, we had they were called conference disks at IBM. John, you could probably tell us more about conference disks than I can.
I think it predated conference disk. It was part of the distributed public library in APL too.
No, the idioms workspace. I don't know if the idioms workspace got into the IBM internal public library.
No.
One of the things that I really wish is that that the internal public library could get outside IBM.
Well, not the whole library, but I thought that got out.
Well, the idioms workspace certainly did get out by way of Try APL 2. And
Good. Yeah.
And let's see, I'm probably a little closer to Try APL 2 than you are, John, because there was a West Coast thing. It came from a lunchtime conversation with Jim Brown and
Alan Graham.
Trimble, and I think Alan Graham and some others in the APL development group at the Santa Teresa laboratory at IBM. At lunchtime, they were talking about what would be the ideal price to sell APL to get it in the hands of schools.
$0, of course.
Zero, yes. And so Try APL 2 was produced to provide APL 2 for schools. I mean, the intent was a complete APL 2 system for doing schoolwork, but limited file capabilities and somewhat limited printing. I don't think the printed capabilities were particularly limited, but the file capabilities were limited. So it wouldn't be of great value for commercial use, but it was intended for schools.
So whose idea was that to give a free system away so that schools could try it out?
Okay, I can date that. It was actually about the same time that the British APL Association was working on IAPL.
Oh yeah, I remember IAPL.
But the most specific thing I can date is it was very close to APL 91, 1991, the conferences at Stanford, and it was before APL 91 that IBM had been getting requests through the mail to mail out copies of Try APL 2. And I helped with that, personally. My most specific contribution was a midnight requisition of envelopes from the San Jose site to take down to Santa Teresa laboratory to mail out copies of Try APL 2. We had a nice mailing party. And in fact, this was supported by marketing. Believe it or not, marketing did provide some support for APL. And we received a very nice big styrofoam box from Omaha Steaks. After my spending an evening helping mail out copies of Try APL2.
Right. Too bad we couldn't just have included that on the AOL CDs.
That might have made a big difference.
All 100 billion of them.
Well, one of
Yeah.
the things that I think is terrific is that Dialog includes APL, for Raspberry Pi.
Yeah, well, when IBM started releasing their own versions of DOS as PC DOS instead of MS DOS, and what did they actually do with regards to the basic? Because Microsoft had their own basic interpreter that they shipped with DOS. They should have shipped APL, IBM APL. But they didn't. Eventually they started shipping Rex instead.
Well, we know that Bill Gates wanted to produce an APL.
Yeah.
Yeah, they were working on it at one point. I'm actually fairly pleased they didn't put it out though, because I think they would have changed everything about it and really corrupted the language. And with their pool, of course, it would have become, the universal approach for APL at that point. Let's get rid of
That's
that
an
right
interesting
to left
point.
part and
Yeah.
so forth.
Well, let's see, my comment about APL with Raspberry Pi actually brings me to my next use of APL. This is a project that I'm actually pretty proud of. I've been handed out by my manager to help with the design of a voice coil motor for a disk drive. And one of the hot topics was, what is the decay time of the current in a locked voice coil motor for an actuator on a disk drive? And the magnetic assembly was pretty different. So the decay time actually meant something quite different from what it had meant for the previous generations of voice coil motors. So anyway, I put together a system to measure the two time constants in a locked voice coil motor. And in this particular design, the second time constant was far more significant than it had been in the earlier design. And so it was a setup using a digital signal analyzer, which I really just used pretty much as an oscilloscope, and a plotter, an HP plotter, and IBM. I used not the fine plot function, the NLSQ function that was in the public library, nonlinear least squares. It's a really terrific workspace. There actually is a TR that I got to determine the two time constants from the data on the trace of the oscilloscope.
Oh, no,
So
there
this
was a workspace for using least squares thing. Wasn't it built into Domino?
Well, this is nonlinear least squares. So you have an exponential.
Okay, so it was a wrapper on top of Domino, I suppose. Somewhere inside the function there would be a
I
Domino.
don't think you even use Domino.
Okay.
I'm not sure, but this is for you want to find the time constant. You're given a function, and you adjust the parameter to minimize the least squares deviation from the estimating function. But we had AP488 included with APL PC version 2, and so you use AP. And of course, Hewlett-Packard, I mean, one of the ironies about Hewlett-Packard is Hewlett-Packard started building computers to control the instruments that Hewlett-Packard manufactured. And, the vehicle for connecting computers to instruments was the IEEE 488 bus, which was called the HPIB or HP interface bus. And APL PC version 2 included an AP488. So I could use APL to run that instrument. That combination of digital signal analyzer and plotter. And I got beyond just the very basics of AP488 to passing control to the computer. So the DSA, dynamic signal analyzer, could run the plotter to produce its output. And then I could take control of the bus, my computer could take control of the bus and plot the information that had been calculated while the DSA was doing its plot. So it's, using the passing control of the interface bus between the dynamic signal analyzer and the PC running APL PC. So that's how I got really familiar with the AP488. And that's where the paper APL catches the bus, which John, you ended up putting into QuoteQuad. I wrote a paper on how to use the AP488 for an IBM technical liaison. Well, let's see. Okay, McGrew, tell Adam about the ITLs. I want you to tell them because you were behind them. You made them work. You and Ray Polipka.
Yeah, I mean, I was a chairman for a number of years, about 12 years, I guess, on the ITL committee. ITL was the interdivisional technical liaison group within IBM. And the idea behind it was that IBM had a lot of groups working on new technology developments at a lot of different locations around the world. And the concern was that people would be doing the same work independently and not realizing that someone else was doing the same thing. It would be much better to be able to collaborate with them. So the ITL committees were formed on lots of different technical fields. They had ITL committees on lasers and many different kinds of technologies, and one of them was APL. In fact, I think that was the only software ITL that we had.
So the different departments were doing APL at the same time?
Well, lots of people use APL.
So this is in the usage, so that they wouldn't double the work when using APL. They could share code, basically.
Well, we had people doing all kinds of development. I mean, we had formally two groups. One was the APL design group in Philadelphia, and the other was the APL development group at Santa Teresa. And of course, those two groups worked together, but they didn't do all the work themselves. A lot of the pieces of it were done by various groups around the world who contributed to it.
Madrid Science Center and the group at Winchester Science Center.
Madrid, yeah. But even apart from that, I mean, work that you were doing, Curtis, you would be in touch with the APL development group, and when you came up with pieces of code or ideas that would be useful for the product, they were all ears. So
my contributions were essentially just kibitzing.
But the idea was they didn't want to have.
Well, I mentioned, idioms as an example where I didn't do anything, but I may have facilitated the idea.
Well, that's not nothing. That's right. That's an important part of it. So anyway, the ITL groups would meet twice a year at a different location each time for APL, and I was the chairman of the group for a bunch of years. There were other people handling it before that, we would get together and talk about applications people were working on, or development work, or new ideas for future development, or just a lot of topics. Good meetings.
Yeah, Ray Polipka did a lot too, didn't he?
Oh yes.
I sort of it seems to me that you and Ray, you each had sort of a briefcase and had all the materials for the ITL in those little briefcases. You guys were really well organized with the ITLs.
Yeah, the role that Ray has often handled, both with the ITL committees and with QuoteQuad, was that he is very good at knowing who is working on what and talking to them and getting them to create papers on it, and then going over the papers with them and getting them ready for publication. So when it came to QuoteQuad, for instance, I was asked at one point to step in as editor of Quote Quad. And I said, I will be happy to do it as the production editor, but I need someone else to provide all the material. So what I came up with was the idea of having a content editor and a production editor. And I'll do the production work, but I want someone to provide the material for me. And that was Ray Polivka. And he has always done an excellent job of that.
And I had the good fortune of being able to hang out with them. My parents live on Long Island, well, did. I mean, my dad died in 1989 and my mother just died a year ago. But I could go out and visit my parents and then get up to Poughkeepsie and go with Ray and John to various, particularly APL board meetings, SIG APL board meeting.
Big API, yeah. Yeah.
So,
Can I ask, when you talked about bubbles and like how you compute with them and such, how do you store data with bubbles and magnetism and such? How does that work?
I don't really want to get into that. The magnetic bubble memory, went away. I don't want to complicate things with a reappearance of a manager who was very helpful in the optical storage laboratory. But back in the bubbles days, IBM actually had a production line set up for producing bubble memories. And this particular manager killed it correctly. I mean, semiconductor memory was getting cheaper much faster than bubble memories were getting cheaper. And so bubble memories didn't make economic sense. And so the bubble memory project got killed. All of us who work in bubble memories have very fond, personal memories of the project, because there's very good work that was done in bubble memories. And you still see echoes of bubble memory work in some of the modern magnetics. But it's not bubble memories anymore.
Yeah, I've put a link in the chat to Wikipedia's article on bubble memory.
Yeah, I saw that.
It's,
Yeah, I'll have to look at that after.
yeah,
Yeah. Mm-hmm.
it's,
I mean, it's sort of interesting. This is a neat technology. And actually, okay, so I'm talking about the APL catches the bus routine. There's a second level manager that he was a second level manager in bubble memories days. He realized that IBM needed to do more in producing optical storage drives, and basically dropped down to a first level manager to set up a department. And his policy was, if you get a paper accepted, you get to go to the conference. And so the way I got to the APL conference in 1992 in St. Petersburg, Russia, was by producing a follow-on to the APL Catches the Bus paper on how you can use APL with AP488 to be a GPIB. Basically I wrote the program so you'd have the computer as the plotter rather than the Hewlett-Packard plotter as the plotter. In one of these types of setups. So that got me to St. Petersburg. And this is the old IBM, which really put emphasis on developing people. Skip ahead. Incidentally, I want to make sure, Adam, that you get John lined up as a featured guest for the Campfire.
oh, trust me, I've been trying to convince him. He can speak about that.
Yes, John, or you can have John and Ray as featured guests.
But they're not impossible. Ray has been there before, but there's always more to speak about, for sure.
And you missed last week, the last APL Campfire, John, where I commented on your talk to APL Germany about a major part of the benefit of APL is the primitive function workspace organization. So you can pick up a collection of functions and put them together in various ways to solve problems. And
Right, you're
I
talking
think
about public libraries?
public libraries, yes,
Well,
and
one of the points I made with that is every language has its own library of code. That's nothing unique with APL, but the part that was more unique with APL was that our public libraries weren't just code repositories. They were collections of everything you could think of, which these days basically we see as um, um, the internet, with websites having coverage of anything you can think of. We had that in workspaces back then.
yeah, and we can pull functions from, I mean, yeah, you can pull subroutines in Python or Java, but it's really easy in APL to pull a few functions from, an assortment of public workspaces to
Yeah.
solve a problem.
So how did versioning work? Where people just wrote error-free code the first time and they published that and that was
Yes.
that? Yeah, that was my understanding from what my father said back in those days. The computers were so slow they didn't have time for bad programmers, so they had good programmers.
No, code's not error-free and things developed. I mean, one of my very favorite APL bug meetings was Gene McDonald's talk that eventually became the Nature Red in Tooth and Claw. Okay, what was the famous game? Life, the game of life. Life, nasty, brutish.
Oh
and-
yeah, that one, yeah.
Yes, and Gene talked about how somebody had at IP Sharp had gotten the book on. It wasn't tech. It was.
No, it was the IBM Tech Journal.
No. This was a book. Not Acrobat.
Oh, so it's
It's a Postscript.
oh,
I think, they'd gotten the book on Postscript that had an example of the game of life written in Postscript, which, is itself the language. And so somebody at IP Sharp, basically put that into APL and passed it around to the other people on the IP Sharp email system. And so the next guy looked at it, and well, several people were looking at it at the same time, but a guy said, oh, well, you can do this and shorten the function. And it went through a half dozen different versions to produce a one-line game of life that Gene McDonald described. And I just love this is an example of different people seeing different ways to improve the function. Or in this case, the objective was making it short. In terms of the number of characters. Okay.
I have a link to that paper. I'll put it in the notes for this as well.
Oh,
Just a link
okay,
to-
good. Yeah, so let's see. So me, well, okay, come APL 2001, I think, was in Scranton. Eric Balin walked up to me and thanked me for the latest improvement to APL Plus. And now, I really cannot take credit for that. I did, make a comment to David Leibtag that wouldn't it be nice if I could simply mark a stretch in the session log and press a key and have it re-executed with, maybe a couple of changes in it. And I made that comment to David Leibtag. David thought about that suggestion and produced something that was way better than what I had suggested, which was, and it's kind of genius. I mean, what David did was produce an unmarked. So unmarked output, I think, was the command. So you would unmark the output and then you execute what's marked, with maybe some changes.
So this is the idea. So this was already on a screen, obviously, not on paper. So this is the idea that you can go back up in the session log to what has been input or output that thing and either change it or just press enter and it will re-execute.
Yeah.
And if you
mhm.
if
It
you change
wasn't just
multiple
that-
lines, it will execute all the changed lines.
I mean, that's in dialogue APL, but not in the form of being able to mark a whole block of text and then unmark the stuff that is output by APL and just keep the material input.
But that's a good point. We should do that. I've been lobbying for a while for an easier way to switch on and off mark for execution or not, because internally the interpreter does keep track of in dialogues interpreter does keep track of what needs to be executed and what shouldn't be executed. Clearly it knows that, because if you change
Yeah.
something, it will mark it like that. Even if you change it back again to what it was before, it remembers that I need to execute this.
Yeah.
So I have like programmed a function key to insert a space and remove that space. So there's no visual difference, but that my key then works as mark for execution. And then you can undo mark for execution, but you can't do it on the whole block. So I'll take note of that. I'll see if I can make John Daintree and
Like what I do is just remove the entire line that's going to be executed. And it usually works. I mean, yeah, I guess it could be annoying for large blocks because they just have to hover with the mouse, right? Could work.
if you remove the line, well, yeah, then it's not going to execute empty lines. Yeah, I guess that works, but you still can't do it with a whole. If you, how do you, that allows you to remove blocks of lines that you don't want to execute, but how do you mark blocks of lines that you do want to execute?
Like just space and go back, right? And then that's the line you want to execute. And
Yeah,
if you
but
want to unexecute it, then I remove that line.
yeah,
completely.
sure, but you can't do that on multiple lines at once. You have to do it one by
No.
one every
Yeah,
line.
yeah,
So
one
this
by
is the
one,
idea:
yeah.
is you should be able to select 10 lines and then mark those for execution, all of them,
Oh, right, yeah.
so you can re-execute things. Actually, something that might be coming soon. I'll give you a little sneak peek. Even though we're talking about the past mostly, but here's a little bit of the future. John Daintree just showed me the other day something where he's begun to track not just obviously the interpreter knows when it needs to print something, but to track why do we want to print something? Meaning you can assign a role to the output. If it's normal function results, or if it's an error, which allows him to color error output in a different color. And it makes it much easier to spot what's an error and what's a result. And so well, where do you want to go with this? Right. So since we So since we know in the session which part of the text were printed because it was a function result, or because it was an error, or because I suppose the user typed it, so it should be also printed. What actually happens under the covers in dialog is it removes whatever you type in and prints it out again. But it's quick, so you don't notice that. And so I suppose it would be possible to mark a block of text or select a block of text and say, mark all my input for execution, meaning it would automatically skip all the output. That would be kind of neat. If you say you change some constant somewhere and then you want to re-execute all the intermediary steps. So something like that could be possible. But sorry, I interrupted you. You were in the middle of the system he came up with. This is David Liebtag, right? He was implementing
I
this.
didn't come up with anything. I said, David, wouldn't it be nice if, and David did the work. I mean, he got the idea that improved, my suggestion enormously. So this is my kibitzing contribution, but just kibitzing. David Liebtag really gets the credit for that. And then another one. What?
Kibitzing is important.
Another one where David Liebtag gets credit was, I was, I was still with IBM. I was the process engineer for the quasi-static test, which is a test of heads going into disk drives, and generating plots to show how the testers were working. And I wanted to get the plots onto the web. So I needed to get the plots into JPEG or GIF format that could be put onto the web. And APL put the output into I've even forgotten the name of the format. But anyway, there was a fellow at IBM, and I'm sorry, I don't remember his name, who put something on the conference disks for converting image formats. And, I ran into some problem, and I went to David Liebtag to ask for help. And David Liebtag looked at what this guy had done and got it into APL2. So now you can, if you're using AP207 on Windows or OS2, but not Linux.
So who runs OS2, but okay.
You can get GIFs or
Curtis does.
yeah. GIFs are very big. Well, I still haven't figured out how to get output from GraphPack in Linux that's any good. Actually, that's the next thing I was going to show you. But anyway, so there's more kibitzing that helped with the product. Let's see, can I share my screen? I can indeed. Here's a screen to share. What do I use APL for now? Well, well, I'm retired from teaching at San Jose State, although I'm teaching a laboratory on Tuesday. But one of the things that I did was look at students' grades using this sort of plot, where the y-axis is the student's score on a laboratory or a pre-lab quiz or an exam, and the space that it occupies horizontally is the credit that it got for the overall class. So basically you integrate the line to get the student's score. I mean, you just add them up and weight them, but I could print those out and kind of rank the students to decide where to pick the place where the grade counted for an A or not an A. So anyway, that's kind of a nice plot that came out of my work with APL, and I've never seen anything like it before or since, and I certainly can't figure out how to do that in Excel. So
doing mathematics in Excel is not fun.
So let's see. We need. I have another example, but I think we need to start wrapping this up. And
well, then you'll just have to
talk about
continue
other
next time.
Yeah, thoughts about who we can corral for the next one.
We'll do that over email instead.
I do have a few comments on some of the things you covered, though.
Good.
Go for it.
I didn't know if you're going to have questions and comments at the end here, but you were talking about versioning a while ago, and of course it's a big topic. There's a lot that can be done with that. But years and years ago, back in the 1980s, for instance, we didn't have that in APL, and one of the things we would often do is just write paren copy functions from another workspace. But how do you know whether that one is a newer or older version than what you might already have in your workspace, or if you're copying them in, successively from several workspaces, which is the most current one? One thing I had proposed that never got implemented was a write paren C copy, which is chronological copy. The idea being it's analogous to P copy. P copy won't bring it in if you already have one with that name. C copy wouldn't bring it in if what you have is newer than the one in the other workspace.
So it would rely on the quad AT.
Blindly bring in a lot of things and end up with just the newest copies of things, but that never got implemented.
So it would rely on quad AT, I suppose, right? The attributes for each function to see when was it
Yeah.
saved.
That's right.
That's interesting.
When we were talking about fine plot, I came into the meeting late, so I don't know if this was mentioned, but Paul Berry had put together a set of programs called Starmap and wrote up a technical report on that, which was absolutely incredible program. This was back in the days of 2741 output. So it was, very primitive by today's standards, but you could go into this workspace and specify any location on Earth, latitude and longitude, and any date, and it would print a map of the sky for you using the fine plot ball on a 2741 with the various size dots showing the intensity of the stars, and then it would label the major ones. An incredible program.
My father had that program in print as well. It was published as a book, so you could actually type it into the computer.
Hmm.
And as well, and I wonder what happened to it. He I think took that code and modified it, because obviously it was producing rather low resolution images on the printer using the separate dots. But he modified it to use it on the VGA or even Super VGA on his computer, as a kind of as a graphical application. I wonder what happened to it, to
Hmm.
Starmap. It would be fun to. Obviously, all the formulas it had are still applicable. The world hasn't changed in that sense. It's just the graphical thing. It would be fun to take that library code and stick some new graphics on top of it and see how it looks.
There was mention made of the Raspberry Pi. I just wanted to comment that there is now, I've been reading there's a 64-bit version of that out. 64-bit Raspberry Pi out. So, interesting.
Dialog is going to release for 64 ARM processors, hopefully soon. Don't worry. We'll get
And
there.
Recently got a Raspberry Pi, actually. I think it's running the 32-bit version.
Yeah, most are still 32-bit, but we should get ready for 64.
And we were talking about
Paul Berry of the Campfire. Be sure to ask Paul Berry about going through IBM's legal department to get Starmap beyond internal use only.
So Starmap, if we can get our hands on Starmap, it's what, public domain, free use, something? I guess.
I don't know.
I don't know what the current status is, but it was, there was a point where, IBM software, went to universities and other people, before, this is long before APL2. And, Starmap was included with the package of stuff that went out with APL.
Right.
And it took some doing with the lawyers to get permission.
And I wanted to comment also that we touched on printing output and problems with that. And one of the problems that was too long-lived years ago was every printer had its own code and its own approaches. So, if you had a Hewlett-Packard printer, you had to have different code for running that than if you had an Epson printer or something else. Just drove me crazy trying to get anything. And in particular, even in the days of putting out QuoteQuad, the only reasonable way, well, originally, of course, that for many years, that was just done by creating it on our own printers and sending camera-ready copy to them. And I really wanted to get away from that. But to get away from that back then, we had to know what kind of printer they used for actually creating the master pages, what make and model and software level they had, and we had to install drivers. So they used an image writer, had to find the brand and model of that and get the drivers for that and treat it as though we had the printer here, the image writer here, and write it to a file, which back then was an enormous file, and send that to them for printing. The thing that finally got away from that was PostScript. And I was really pleased to be able to work with Joey Tuttle on a PostScript font for APL, which we needed for the APL Systems Journal, going through the same kind of problem. How do we print this stuff? And my other touch with PostScript was in developing APL2 when I was working for the development group. One of the tasks I had was finally writing a PostScript driver for APL output, so that it would be relatively printer independent.
Well,
those are my comments.
Was it APL 93 in Toronto? Showing APL2 for OS2, and the slogan was with OS2, APL2 connects.
Okay.
And I thought, that's nice. But it came home to me when I was visiting Ray Polivka. And he had picked up an XY plotter at a yard sale. It was an RS-232 connection to the computer. I mean, I actually had to, borrow his soldering iron and modify a cable to get the RS-232 connection between the plotter and the computer working. But then, I could, use GraphPack and the plot would show up on the plotter. You could ask it to basically just send stuff to print, and it would be printed on the plotter very nicely. Didn't have to get any special software other than whatever plotter driver was in the computer.
This was at APL 93, you said, in Toronto. Yeah.
Yeah.
I think
By
that
the way,
was-
the other surprise that we had at the APL booth in '93 was showing APL2 for the Sun workstations.
Yes.
That was a product
So
we actually
Laris was a
created at
thing. Yeah.
IBM.
Yeah.
And we couldn't, I was in charge of setting up the booth there at APL 93 in Toronto. And because of import restrictions and duties, we knew that we couldn't easily take computers and terminals up there from Kingston, New York. So the solution was to borrow them from locations in Toronto, and getting, IBM PCs to use was no problem, but we also needed a nice Sun workstation. So I went to Sun in Toronto and talked to them and said, we're setting up this booth at IBM and we want to show off your Sun workstation. They were pretty suspicious of this, like, why would you do that? And I think they were really expecting us to show that, the IBM systems greatly outperformed the Sun system. Of course, that wasn't our goal at all. We just had an APL interpreter for the Sun system. But they wanted to make sure they were in a good light, so they gave us the best, fastest possible Sun workstation. So thank you very much.
Mm-hmm.
Did
That worked
anybody
out very well.
from some come around and look at the booth?
Yes, sure.
Well, let's see, when we were in San Antonio, I think we picked up some equipment from IBM in San Antonio, didn't we?
Probably so. Yes.
I got to hang around with the APL development people at these conferences, even though I wasn't, actually part of those departments. I mean, my job was usually putting APL keycaps on the keyboards.
Fine. So
You mentioned TRs also. When I was in Endicott many years ago at IBM, I got interested in the technical reports that were being produced every week. And there was a booklet that was sent around every week with new technical reports that had been published at IBM. And it was a pretty sizable list that would come out all the time. And I'd go through that and find ones that interested me and order them. And one thing I found was that there were no abstracts in the booklet. It was just titles. So the authors, knowing that, would have these enormously long titles, a study on this regarding that, but with corrections for this and, involving that and so on. It'll be like a whole page title on the technical report. Some of those were pretty interesting. The one that caught my eye, though, was the one that was simply how to build a bathtub. What?
it doesn't sound like an IBM thing. What was it about then?
I didn't order that one.
Oh.
Well, another thing that we should mention while
Capacitors,
you're
maybe. I
here
don't know.
is you wrote a really nice introduction to APL manual that was part of the early APL2 releases, wasn't it?
Well, I read the APL manual. Oh, you mean, yes, the
The introduction to APL, I think, was the title. something
introduction
like
to APL2, right? Yeah. Yeah, I
there
wrote that for the internal user product and also for the released program product. Two
So,
versions.
Curtis, You still have more things on your list of things that you have used APL for, right?
Well, like one more item, which is, of no consequence other than it, APL is really nice as a tool of thought for sorting out experimental data. And I don't think we need to spend any time on that.
Well, that's kind of what it is intended for by Iverson, I would
I mean,
say.
I can show you, I probably got the plot sitting here that I can show you.
Either that or you can wait for next time. Either way, it's up to you. I'd be happy to hear more of your anecdotes of things you've used the APL for if you have more in the next episode, if you're okay with that.
Oh, okay. Let me share the screen and I can show you a plot of let's see, click share screen, and I hope this is the screen. Now, there's an experiment that's done at the Materials Engineering Laboratory called Electrical, Optical, and Magnetic Properties of Materials. And one of the labs is a Hall effect laboratory. And now the data look a lot clearer here than it did when assume all the points had just black dots rather than being separated into circles, squares, and dots. But
Those are not squares, those are quads, aren't they?
Quads, yes. I should call them quads. Anyway, so I've got an APL function that allows me to choose the plot character by whatever criterion I choose, and in this case it was the sample current. And so anyway, this was pretty hard for anybody to analyze, and I realized that the students had gotten the sign incorrect in some of the data, and so I was able to rearrange the sign and again separate the sample currents, and so you can see now they fall on nice lines with a dependence on the sample current, and of course the least squares fit is really easy in APL, so you can include the sample current as well as the drive to the sample. And so when you make the correction for the sample current, everything goes on to a nice line. And so, that's just an example of, being able to plot things easily in APL
And there,
as an aid to thinking about problems and figuring out problems.
the eagle eyes can spot the domino right there. It's in the plot.
Yes, and it certainly was a domino that I used.
It's right there.
I did indeed put the APL expression in the plot for the other. This is a discussion group for the other teachers for Matty 153, and incidentally, I did put the solution into Excel so that they could plug data in. But boy, doing multiple regressions in Excel is just a pain in the butt.
So I don't know. Brian probably doesn't know this. I don't know. You familiar with the quad divide, or also known as domino function?
I thought it was a matrix function. No, I'm not. I've never used it. No.
It is.
It
It's a matrix. It's also known as matrix division.
Yeah.
But it solves linear equation systems in one go. You just give it a matrix of all the coefficients and a vector of all the the sums, all the values. And then it solves all the variables, gives you the result. And if the system is overdetermined, it will use the least squares fit to give you the best possible solution, which is exactly what Curtis is doing there. And because with real world data, you can have plenty of data points, but they don't line up exactly. So yeah, it's a powerful primitive, rarely used if you're not doing exactly what it's good for, but when it's what you need, it's nice.
Interesting. No, I've never used it. I was actually thinking of adding like for a tiny bit. I'm thinking no, I probably won't add it, but I might want to try ray tracing and adding so I was messing with like sine and like how you can draw a circle, a perfect circle with like the distance and like using what's it called, Pythagoras? No, yeah, Pythagoras, right? A squared plus b squared equals c squared, etc. And like I was thinking, what if I made a 3D array with numbers, and instead of making a normal circle, I just make a 3D circle and do like ray tracing from a point, right? And I was like, I could totally do that with a few sine and tangents. And I was like, no, I'm not gonna mess with that.
Well, you can. That's
I
and in those cases, you might actually end up appreciating how the circle function works. A lot of people go like, why do you use numbers to specify the function? That's just strange. But often you want to take both the sine and the cosine of the same angle.
no,
And-
dude, I've actually made a function APL that takes 2 points in 3D space and tells you the angle that one point has to turn to look at the other point. There, in that function, I used about like 5 circle functions. Like the circle function is actually really beautiful in how it's and how simple it is.
Yep. you
Like
can
I was challenged by a friend of mine to code it because he coded it in Java in like 20 lines, and I made it in like 1 line, which I
course.
was so happy about.
Yep. Yeah, often you can end up with an outer product of circle functions. So you take a bunch of circle numbers on the left and a bunch of angles on the right, and you get the whole table of everything in one go. And then you can combine them again the other way around when someone's using an inner product, the circle as well. Anyway, lots of that. So we are a bit over the hour already. Curtis, thank you so much for running it basically.
Well, thank you
Running
for
the
your
show.
patience in listening to me.
You know,
And
let me comment too. Curtis always minimizes his involvement with a lot of things here, and sort of puts himself down on this. Curtis is a good guy to keep in touch with on all these things. He was very involved with APL for many years, and keep in contact with him on all this. Thank you for being on
I
this,
will.
Curtis.
But I'm also very tempted to say that he's the special guest for this episode, because that's really what you've been doing. Something very similar to whatever all the other guests have been doing, is telling your history and what you used APL with. So that doesn't mean you can't be here again. It's always welcome back. So
Well,
thank
I
you so
wanna hear
much.
what other people have to say.
What do you say again?
I want to hear what everybody else has to say.
Yeah, well, we have to bring them here and drag them in, kicking and screaming.
I think this is something where we can put McGrew to work, getting people in. I mean, I've been somewhat unsuccessful in persuading people to actually participate.
It's hard.
Great,
Got
Cliff,
probably ambiguously lined up. Paul Berry is somebody who, has been, we've actually talked to him on the telephone and exchanged notes, but actually getting him to log into Zoom has been unsuccessful so far.
Yeah.
Ray
Well,
Polivka is the guy who we use as the content editor for Quote Quad. He can be the content editor for this also. He's in contact with a lot of people. He can talk people into gathering their thoughts and making a presentation.
yeah. Well, maybe I should speak with him. He's very much in favor of publishing more materials or APLs. So
First,
I'll
we have
speak
to
with
get him involved in being part of these meetings.
Oh, he already has been. He has been a featured guest
yeah.
here. So,
Yeah.
so definitely.
Comes
Maybe
from
well, I
the
was just thinking of maybe I should try to get Pete Donnelly to come in as well. He must have some stories to tell. And maybe I have more influence over my own colleagues. I don't know.
Yeah, well, I was really disappointed that Adrian Smith didn't show up last Campfire.
He's busy golfing or something, fishing, whatever people do these days. Anyway, let's let it be there. I'll start over the process of trying to drag people in for the next episode in 4 weeks. Thank you so much. There are not a lot of people here today, probably because I didn't make any advertisements of it. I feel kind of weird about inviting people when there's no featured guests lined up. But
Yeah, there was also no preview of it on the website as far as who was going to be presenting. So
yeah,
that
because
the attendance
because I
also.
don't have anybody who is going to be presenting. So yeah, you're right.
No, I should explain that I had this long list because, it's just Adam and me. Actually, there are a couple of other people that showed up at the last one. But Dom asked me, what did I use APL for? And I was caught flat-footed with no idea of what to say. So I.
But you haven't even
list.
finished, no, Curtis? You have more things on the list that you didn't go through today?
No, we've come to the end of the list.
You come to the end? Okay. So then I'm putting your face on this episode, wanted or not. Thank you so much, everybody. We'll see you around.
Yeah, thank you.
Thank you.
Bye.